Morning, ladies and gentlemen. Here is Prof. T.S. Molokomme, as you know me. So today we are going to do work, energy, and power. And then here, as we can see, there are three terms, which is work, energy, and power. So I just differentiated them like this so that we can understand. Now, work. Let's just look at work. And then we know that work is the product of a force and a displacement at that angle. A work is the product of a force and a displacement at an angle. It means by a means of a formula, I can say work is equal to the product, and the product means the multiplication of the two. And then it means it's the product of the force and a displacement. You can show it by changing x at an angle. You know that cos theta. And then there is a variety of work, where work can be positive and work can be negative. So I want us to just look at these things. Work can be positive where the displacement, I think we are talking about the product of a force and a displacement. It means work is positive where a force and a displacement are traveling at the same direction. It means a force and a displacement must be parallel to each other. So we can show it by this way. If we have an object, and then the force is going that way. For us to find the work which is positive, it means the changing x must be parallel to the force. Where we find that if they are parallel, let me show you by a vector. It means if they are parallel, it means the angle between these two is 0 degrees. It means we are going to have y is equal to f changing x cos 0. And then we know that if we can punch our calculator, cos 0 is equal to 1. It means the force is positive and then the displacement is positive. It means our work will be positive. So let's just go to work which is negative. If we have an object here, for us to find a work which is negative, it means the force must be opposite to the displacement. It means our displacement will go that way and then the force will go that way. It's where we're gonna identify the angle. Let me just indicate it by a vector. And then it means if this is our object, and this one now is changing x, and this one now is a force. It means the angle between the changing x and the force is this one. And then we know that angle on a straight line is 180 degrees. It means we are going to have theta is equal to 180 degrees, where work is equal to force changing x cos 180 degrees. And we know that cos 180 degrees is equal to a negative number. It means already our work will be negative. And then, without using some examples, let's just go to energy. From grade 6, we know that energy is the ability to do work. Is the ability to do work. And then there are major types of energy. And then the first one I can say the kinetic. We have a kinetic energy. We have a potential energy. And then we have a mechanical energy. So I'm gonna differentiate these three energies. A kinetic energy. And a kinetic energy, it means we are going to focus on velocity, because we know that kinetic means movement. It's a movement. And then it means kinetic. We are going to talk about a velocity. And then the formula to calculate our kinetic energy, it will be EK, which is standing for kinetic energy, is equal to half mv squared. And then remember, we have said kinetic energy is the movement. It means we're gonna have a velocity. Yeah? And then now let's just come to the potential energy. The potential energy, I can abbreviate it by EP. And then potential energy, I can say it deals with the height. With the height. Yeah? It means now we're gonna have sorry. Potential energy is abbreviated by potential energy is called EP, mgh. Okay? So now I want us to differentiate between a potential energy and a mechanical energy. A potential energy is where we're gonna say mgh. No? And then a mechanical energy, Emech, is called to, and then I can say the mechanical energy is the product, is the sum of a kinetic energy and a potential energy. It means E mechanical is equal to EK plus EP.
Just that.
It is kinetic energy plus potential energy. So now, let's just come to power. You know, power. Power. And even on church, they always say power. It means yes. And even here, let's just set another scenario. We have said energy is the ability to do work. Okay? Now, power. Power is the rate at which work is done. And then I'm going to say the formula to calculate the power is equal to work at that time, at that particular time. It means here, I'm going to substitute it by work. We know that work is F changing X cos theta. Therefore, I'm going to say F changing X cos theta divided by time. It means power, I can define it as is the work done on an object at that particular time. Yes. And then, guys, I'm sure this is the end of my explanation. But remember, this is Prof. T.S. Molokomme. I'm just around the place. I'm just around Limpopo, University of Limpopo. Let's just meet later, guys.